Okay. Yeah, hi guys. Everything. Hi guys. In this video, I will be discussing about insert intervals. We have discussed last about merge interval. It is just extension of that. Little modification you will make, and you will be able to solve this question. So let's start with this. This is so-called insert intervals. Okay. So what this problem says, you will be having some pointer. First, it will give you some intervals, but they are non-overlapping. Okay, just take care. They are non-overlapping and increasing, which is important pointer for this. Okay, so you will be given a 2D vector. Suppose right now I have 2, 4. It should not be overlapping. It should be non-overlapping. Okay. So after this, think for 5, 7, pose 8, 10. Okay, so this is the given input. Now you will be given one more interval which you have to insert in this, and you have to get the merge interval, like how we have done the last time, right? So let's take an example for the insert. Suppose it is 3, and suppose this is 6, 7. Suppose this is 1, 2, and this is 3, 5. Still, it is non-overlapping. Let me insert. So this is the correct place where we can insert. So after insertion, what it will be? 1, 2, and 3, 5. Correct. Okay. So now we want to merge this, but main intention is how you are going to put this. So first, the naive approach. What comes in my mind is whatever you have given. Suppose let's example 1, 2, which we want to insert, that is 5, 6. What it's coming as a name, I will try to insert this into this vector, then I will sort it. Okay. As soon as this is getting sorted, this vector will be sorted after insertion, and then we can apply the merge. That is easy, right? But see, what will the time complexity for this? What will be the time complexity? As you are going to insert, what will happen? Here we would be able to, let's do it pushback. Okay, first we are inserting at the end, so this will be 5, 6. Correct. Now let's sort them. After sorting, what you will be getting? 1, 2, 3, 4, 5, 6, and 7, 8. Now you apply the merge. Will this work? Yeah, correct. Same problem, the last problem it will come. So what will the time complexity for insertion? That is, suppose at the end we are inserting, so we go 1, so that is not an issue. But for sorting the whole system, suppose it is n element after insertion, then it will be n log n just for sorting. Then we are applying big O of n for merge. Okay, so the total time complexity is big O of n plus big O of n log n, which is nothing but log of n plus 1, which we can write n into log of n, because this is nothing but log of n. Correct. So this would be the final time complexity for us. But just can you think, can we trim down the time complexity from n log n to big O of n? See, what we have to do, just we are trying to insert one pair only. Just for insertion of one pair, do we need to sort the whole system? This is not fair, right? Because already this is in the increasing order, and just for one element, do we really need to sort the whole array? No, obviously not. So We will think little more on this, how we can do it. Let's take a test case. First, suppose it is 2, 4. This is what I have. Now, sometime it might happen. I have new interval which might be inserting here, which might be inserting here. That two case only we have to handle. And other cases, what I will do is, I will just tell, I will be finding a first which is just greater than that. What I mean is, suppose, leave for the edge case for now. Suppose we have to insert 4, 5. Okay, so I will try to find a position which is just greater than 4. So this is the place. So I will try to insert it at this index. So what this means is it will shift it. So it is 2, 3, 4, 5. Correct? So if it is not an edge case till here, it is fine. But a number, if it is coming for this index or for this index, then we have to take care. Just we will be checking a number is that, suppose I want to insert 1, 2. It's not overlapping. For now it is overlapping. Just for right now, just think about this. If it is 1, 2, then how we will be taking care? So for a number like this type of edge case, we will be putting two edge case condition, where I will just check is that number which is just less than this or not. If it is, then I will tell okay, you insert it at the beginning. Else, if a number, suppose it is 11, 15. If a number just greater than this, I will put it at the end. Correct? This is sorted. Let's put this. Let's put this sorted, right? But suppose if a number which is equal to this or equal to this, how we will handle? How we will handle that case? So suppose if it is 1, 7. Suppose 11, 18. So at that time also, just we will check is that equal or not. If it is equal, either you are pushing here or either you are pushing here. That is not an issue, because by merging it will get handled. Suppose if it is 1, 7 or 1, 2. Correct? So as 1 is less than 7, it is overlapping, or it is 1, 7. 1 is less than 2, it is overlapping. So if it is overlapping, it will take the maximum of these two only. So either 1, 7 or 1, 2, 1, 7. What will be the output? 1, 7. What will be the output? 1, 7. So you no need to worry about that. Okay. So if you are coming a number which is just equal, blindly insert at this position or this position, that is your choice. That is not an issue. Let's take example for the last. Suppose 11, 18 I want to insert in 11, 15. If it is, then also we have 11, 18. If it is, then also 11 is less than 15, that's 11, 18. So you don't need to worry about if it is equal. You just check it. If it is an edge case, like if a number which you are trying to insert, if it is coming before or after, just those two cases you have to handle. If you are able to handle that, this problem is nothing but trends down into merge interval. Okay, so this approach we are going to try and we'll resolve this problem. Okay, let's check it. What will be the time complexity? Time complexity is nothing but big of n only. In big of n, just we are trying to insert. Means suppose if any one thing is one interval is coming, and that time we are at most we are iterating the whole. Suppose this is the point till here to here, or my value is going to be inserted here. So this will be totally n minus 1. In the worst cases, it will be n minus 1. So I am taking it as big of n for insertion plus big of n for merge, which is nothing but big of 2n, which is better than big of n log n. Correct? So yeah, it's fine. The space complexity, how we will resolve it. In the earlier video, I have solved this question with constant space complexity that I will be using in the code. So let's get into the laptop and we'll submit the code on the LeetCode. We'll insert. What we have to try, as we have discussed, first we will checking the edge cases if it is begin or at the end. Okay, okay, fine. Let's take this. Suppose if new interval of 0, if it is less than the first one, right? If it is less than the first one, so the first one with their first index. Okay, as we have discussed, if it is equal to also, then it will be handling all other edge cases, correct? So if it is, then what we have to do, we have to insert, right? So where we will be inserting in the new interval, we are going to insert at the beginning. So let's, in the new interval, what we will be doing at the beginning, correct? What we are trying to, which is wrong, we did wrong. So it should be the interval, not new interval. Control X. Let's put this one. So we want to insert this new interval, right? So if new interval of 0 is less than equal to, that is fine. Then we will be making a merge method. Okay. So in the merge method, what we will do, we will just pass these intervals, correct? That's it. Now we will check for the another edge cases. Let's take the same thing. Let's try to solve this. So if new interval of 0 is greater than or equal to what? End 1. So let me take it. So what we will be having, sorry, intervals, correct? So let's take this size, and what we are telling, if new interval of 0 is greater than equal to, that's fine. So from the last one, correct? So if it is, then we are trying to insert at the end. So let's insert at the end. Till now it is correct. So let me go and check in middle, means in between. It is not at the end or at the first. And what logic we are trying to use. Okay, so what we will be telling, if are this new intervals, so as soon as we are getting any intervals for I of 0, if it is greater than this new interval of 0, correct? If it is happening, then I can see, yeah, this is the place where we want to insert. Let's try to insert that. Okay, so this would be the begin, and let me insert at index I, correct? And let me break. We can return, but this method will tell, this function will expecting something to return. That's why I am just breaking it so that I can work to return it from the end. Okay, so what we will be doing, we have this merge method where we are going to pass the intervals. Let me define this merge method where they are expecting also same thing as we have defined. We are passing it by address so that it will take it will not consume more time. Okay, so what we are passing, this intervals we are passing. Okay, let me take the code from the earlier question. We are having this merge interval, right? Merge intervals, the last day whatever we have solved, same type of method we have defined. Let's take this and put it here. Let me remove this underscore merge to merge. I believe everything is fine. Yeah, let's run this code. There is some issue what we are having. We are having to intervals dot insert. Sorry, this is wrong. Okay, we have to pass this intervals, not new intervals. So that's why it is getting wrong. We have to pass this one. Let's submit this. Okay, there is one edge case. Okay, sorry. Suppose as they have mentioned in the constant, the size might be 0 as well. So if it is 0, then that don't make sense, because we are trying to access directly the 0th index in the new interval. Sorry, in the in the interval 0th index we are trying to access, which is not available. So what we will tell, if index is not there, then let's return this whatever it is. If it is empty, then we'll return empty. If it is something, then we'll return that one. Let's try that. So this would be wrong because they are expecting 2D. Let's return now. Okay, submit this. Yeah, we are able to check this. Okay, fine. So what will the time complexity for now, and the space complexity? So space complexity is the constant. We are not using any anymore. And for the time complexity, this is big of 1, big of 1. Now here we are utilizing big of n, correct? As soon as we are done with the insertion, then we are firing a method called merge, which is taking the big of n. So it's big of n. For here also you can see this is the big of 1. Till here it is big of 1, but it will take big of n. It is also big of 1, it is big of n. So you can say, okay, here also big of n, big of n, big of n, but it will return here. So it anyhow it will at most will reaching at the big of n. So for these two cases only big of n. For this case it will take time at most big of n, and at the end of the day it will be calling this merge method, which is big O of 2n. And the space complexity anyhow it is constant only. I hope you have understood this problem. And if you really like this video, then don't forget to hit like, share and subscribe button. Please share it to someone who really need this type of video. And then we will meet in the next video. Bye bye.